I just did. And so I'm assuming that up in your command velocity, you're setting that grab command time.
So here's stop base. It just sets your linear velocity, angular velocity 0, and then that gets sent out. Yeah, and previous time, and then you're just loading that previous time here and comparing it with your current time.
But that G_prev_command_time, do you set that in the command velocity function, the the callback function with your current time?
Yep.
Okay.
It's right in the command callback.
So it's a one way to get after if you lose network connectivity.
Yeah, it works great. If the tractor loses connection to my cell phone, it just stops, and then I can just walk closer to it, and then it will pick up the command and then start moving again.
Jeff, I was just asking Matt, I'm hoping to do test driving in the daylight hours on Saturday, and was just thinking through network connectivity, and when I lose network connectivity, whether it's going to fail gracefully or not. So that was what triggered the conversation.
It's always good to test that stuff ahead of time.
Do you have an LED or something that you blink or flash or something around network connectivity?
No, it just simply, well, right now the only network I have is my remote control. And if that gets too far away or turns off, it's after a timeout, it just shuts off the e-stop and kills everything. Or doesn't kill everything, it just keeps the motors from turning. So I haven't got a ROS connection in there yet, so I don't have any real networks yet.
Well, as far as status on my side, let me just zoom, where'd you go? So as far as status on my side, I've updated my instructions for test steering control and test transmission control. So I think both of those are at a point, both writing wise as well as physically on the tractor to test it. So one of the things that I was working through in this particular step was around getting the joystick connected and getting the command velocity statements where they needed to be. You can scroll up past. So, and again, these are just instructions, but so I, updating these launch files. And Matt, you gave me another version of that, so I'll use that to change these. But prior to those, your input, this is what I was updating, and then the same thing with the testing the transmission and writing down the steps to go through on testing that out. So that ended with issuing this command until the wheels moved, and so that's been updated. And yeah, I think I'm ready to tele-op control the vehicle. So hoping to run over something. hoping to run over something in the daylight hours instead of, I was really close to saying, you know, I could mount a flashlight on it or something and just running around in the dark, but I chose not to do that. So we'll see how that goes. And then I'll have to go through the process of getting the GPS out and getting the IMU connected after that. But I mean, Matt, just to talk through it for a second, if you don't mind, you know, step one in my mind would be to get the new, what I'll call nudge value for it to move in grass versus what I've got now, which is, you know, a level concrete floor. And then I've got to adjust the PIDs both for speed and steering for grass versus, you know, sitting still on a concrete floor. That's what I'm thinking I need to, how I will spend my day testing. Does that make sense to you?
Yeah, I found I didn't have to adjust the PID, but you may have to. The one way that I tone down the steering is to change the effort, the max effort. And so I usually lower that down. And then if I get into grass, then I bump that up a little bit. But for testing up on blocks, I lower that down so the steering's not moving around too fast. And
I think
then
I'm at 50 at the moment.
you're at what?
50.
Okay. And then for the velocity, all I do is just change that nudge value and then go. That's what we did down south, and it worked okay.
Cool. That's what's going on with me. No new purchases. Haven't spent any time on the servo that came from Alibaba, or no, MPJA, I guess. So I haven't had time to mess with that.
That's pretty exciting. They put a potentiometer in there. I was hoping that signal would be a lot cleaner.
I haven't checked it yet.
Yeah, it's funny. I actually found the motor and the gear a year or so on eBay, and so I still have it. And you know, whomever is selling them now, I don't remember. They've now added the motor controller, so it was funny to pick
progression.
Yeah. And like, because I had actually spent you know, a year ago I bought the motor, the gear motor, and the, you know, the DC motor that was attached to it, and I shipped it to guys that were making motor drivers and the potentiometer, the magnetic deal. They were in Athens, Greece, so it was a whole big drama to mail that off to them and get it back from them, and so on and so forth. And unfortunately, their motor driver wasn't really ready for 5 amps of current, because they were sticking them inside of little teeny tiny servos. But anyway, I digress. Jeff, what's going on in your world?
I don't know. One thing I've been thinking about is trying to figure out my power sequencing for my Raspberry Pi. And I'm going to go back to that one of these days and work with that. So I'm going to take a Raspberry Pi, one of those little 5 amp switching converters, and then add a microcontroller so it watches, see if I have a power switch. You can either do like a toggle switch, so it's just up and down. So up is run mode and down is stop mode. Or you can just have the input coming in like an ignition switch input. So like on a car, you're getting, as soon as you turn the key on, it would recognize that and it would boot up the computer. And then when you park your car and turn it off, it would just automatically cycle the whole thing down. So I'm going to get back and look at that some more. And then also, we were talking about the bag files, and I picked up a cute little the cheapest solid state drive I could find. I think it's 60 gigabytes at $25. So I got that, and I plugged it into my laptop and copied all my pictures out there, and it seemed to be pretty fast. So it's something else I have to add on. So then back to my saga about plugging in multiple devices. I'm looking at, I've got 4 USB ports on the Raspberry Pi, and I want to use 2 of them for my 2 GPS receivers, and then I'll have to have 1 for the solid state drive. So I'll probably take the 4th one and then run to a hub and then hook up other things, because I still need the Verizon hotspot, and I need my motor controller, or my my low level controller on the robot. So I'm sure it's going to get used up fast, and so I'll have to see if we can get all that to work. See if we can get it all put together and get it all talk at the same time.
I mean, I don't know. I'll dig up the link to the one that the hub that I'm using. I don't know if you want to try it or not. It served
Well,
me.
I'm just going to stick a regular, whatever I got laying around, to put on there just to verify everything. So I know you had that fancy powered one, but I was just going to plug in a normal one and see if I can get everything to work.
Speaking of power, do you monitor your voltage, your battery voltage?
I've got that little battery monitor thing on the back that just you can walk up and look at it and see what the voltage is on it. And other than that, I haven't actively tried to monitor it. And anyway, if you've got an Arduino or whatever with an analog input, you can just put a voltage divider to get it down to the appropriate range. You can measure it that way if you wanted to.
Yeah, I think I need to
And
do
actually,
that.
mine is more important to monitor voltage, because see, you've got a gasoline engine to hopefully charges your battery while you're driving around, whereas mine is just a battery. I charge it up, and then when it runs down, then I'm dead. So there's a slight difference between what I'm doing and what you guys are doing.
Yeah, I mean, you would think. Yeah, I think that's the way of just saying, hey, you should never run your battery down, but I did. And, then when I try to crank it, it brings the voltage so low that then it won't power the RPi, and the RPi, reboots. And so that was all kinds of drama for me. But
Yeah, back to that old problem.
yeah.
So if your battery is charged, does starting the engine reset your electronics, or does that everybody happy as long as you don't run your battery down first?
Everybody's happy as long as I don't run the battery down. So another, I guess, safety thing to monitor. But yeah, I was assuming it was as easy as a voltage divider and feeding it into an ADC pin on one of the boards. Do you do any voltage monitoring, Matt?
I don't, but that's a nice feature to have.
That's one of those things that goes on the whole list of, if I get some time, I can add this on and have all kinds of headlights. You can put headlights on it. And your lawnmower doesn't have headlights, or did you rip all that stuff off?
I ripped it off.
Oh man.
I know. And then I'll tell you my sad saga. My wife, she's like, well, he doesn't need this hood thing anymore. So that ended up in the trash, and there went my headlights. So
Huh.
I was thinking the other day that I needed those headlights, and anyway.
Well, you can just get a flashlight and some duct tape. That'll take care of
That's
it.
exactly what I was
tape it right on there.
So I hadn't seen this SparkFun thing. Did you read this SparkFun thing?
I just basically looked at it to see that he had a whole list of parts he was using there, but I didn't look at it hard enough to see what he's doing. I saw he had Raspberry Pi 4 and he had a U-Blox F9P receiver, and I forgot what he's talking about, how he did his steering. I didn't look at it hard enough to figure that out. And the question, he says, am I crazy? And yeah, of course he's crazy. Who would modify a lawnmower to drive around autonomously?
Nobody.
You'd have to be crazy to do that.
Yeah, I'm just cantering through it now. I don't. Matt, you should invite him into your group.
They're telling me he's crazy.
Yeah. And I sent him a LinkedIn request. It'd be fun to have him talk about. I really like this J Rover board that he built for the Nano to bring out all those pins.
He made that himself.
I think so.
That's cool. He's got some skills.
Yeah, I think the board had his name on it, so I'm sure he made that himself. Well, here, let me go grab something I was going to show you. So
he's running the Teensy 3.2 on that one, but he says he's going to upgrade to the Teensy 4.0. But having that DIYrovers.com is the address.
So we had a case where, you know, you deal with big stuff, and you got automotive type wiring, but you need to connect it to the real world. Well, I dug through my junk box and found this thing that I found one time that's got terminal strip on one side, and it's just got a like a connector for ribbon cable on the back. And it turns out if you just use the little jumper wires like these, they will plug right into those. So what I ended up doing is using the just the connector for the encoder. So I used one of the 5-pin blocks, and they just plug it on. So it plugs in across here, and then on the back, the 5 over here, then the first 5 are connected to those pins. So I had one encoder plugged in. So I had one encoder plugged in here to these 5, and then on the bottom of the board, I had the other encoder plugged into these 5, and then on the top, I just hooked up to what screws I wanted. And then I thought, since this is just some junk that I had laying around, I thought, what can I get that you could order off the shelf, so you can tell somebody, well, here's what you need to do. And I found this thing. It's supposed to be for an Arduino, and you're supposed to. Oh, that's not what I thought it was going to be. Oh, I see. The board is scored down there, so if you want, you can snap it right down the middle. Can I see right down the middle of the board? See, there's that groove in there. So theoretically, I can snap this apart like that. And then, see, this will give me screw terminals. Let's look at this one. So I got screw terminals, and then it's also got these little pins sticking up, so you can plug into those. And then it's got the row for the Arduino that's got the female pins here, and it's got the male pins on the bottom plugged right into an Arduino. I think it came with the 2 pieces, and it said it was $5.95 is what I paid for it from that MPJA. I was looking at eBay thinking everybody would have lots of little things to do this. And this is the best thing I found so far. There's a quick thing I found, and I haven't even looked at these hard enough to see how they're going to work, but I think the terminal pins are labeled, and then the little jumper pins sticking up. No, it says.
What do you use the one that was in your left hand for? The one that didn't have the female and male pins?
On this one?
Your left hand. Oh, your right hand now.
Well, these are both. See, originally these went together like. They actually went like.
So it's meant to be a shield.
Yeah. So before I broke it apart, here it goes like that. It doesn't work either. I don't know how I did that. I have to go look at the picture. But originally this was hooked together, and this is meant to plug right into. Here's your pins right there. It plugs right into an Arduino, and I snapped it in half because I didn't want it for an Arduino. But so I don't know here, because now for some reason I got all the terminals in the middle of the board, which isn't where I want them. So I don't know. I don't know how I did that. Anyway, I'll have to go look at the original picture to see how it's supposed to work. So that's one way to connect big wires to little wires without. Otherwise, you have to make the little circuit board to solder all the wires on, and I did that, and then thought, this other way would work better. So I got this, because the first time around I didn't have a way to power the encoders, so I had a little perf board with one of those little switching encoders on it, or switching regulators on it, and then just soldered the pins on to be able to connect to it. And then we decided, well, we're going to use our Danfoss controllers to run to connect to the encoders, and they will also put out 5 volts. So we just connected right to that. So all I needed was somebody to get from the big wires down to the little wires. So that worked out really well.
Cool.
If anybody sees something like that, where it's just got a board with terminal strip on one side and then the pins sticking up you can plug into that, make note of that, because it'd be good to find something, a standard way to do that.
I mean, you
that you can just plug in your own.
Do what?
What were you asking for again, Jeff?
If anybody sees
Just
something,
has a row of,
if anybody sees something like this that has the terminal strip here and then some kind of pins where you can plug in the little jumper wires. And see, like this one, you can get ones, if it's got the Arduino type, it's got the pins sticking out the bottom, but this is nice to have them on top like that. So if anybody just runs across something that just meant to do this, where it just got, say, a straight row of header pins and then the row of connectors on there, that would be handy to use. Although now that I'm looking at this, the row of little pins that are sticking up, it says G, V, and S. So I assume that's ground signal and voltage. So it's only on this little board, it's only the analog pins. So it's got A0 through A5 right here, these three right there, and that just connects to these analog pins. So the rest of them don't come out on the tops, but I assume they're all connected here on these Arduino pins sticking out the back. I haven't really looked at it yet to see how it works, but that's an option. So if you don't want to do a lot of soldering, this is one way to just grab a board and quickly connect it. But this one is a more generic type thing where every screw terminal there is connected to a pin there that you can plug something into. And if you wanted to, you could plug a ribbon cable into this. But this is just something random I found at a surplus, 20 years ago. So I don't know. I didn't see anything that showed up. When I was searching on eBay, nothing popped up that I could just order easily. So I was just looking for something.
You had actually mentioned before a Teensy breakout board, and I was just trying to find it. But are you looking for an Arduino one or a Teensy one? Or it doesn't matter?
I just want something generic. See, this has nothing to do with the microcontrollers. This is just simply I've got big wires coming in from somewhere. Say, like on your garden tractor, you've got big wires coming in from switches and whatever is on the thing, you need to connect it to your little boards. So this gives you a way to, then you can plug the little jumper wires and hook them up to your Nano or your Arduino or whatever you're using. So it's just a convenient way to get from big wires to little wires.
Yeah. Matt, what's going on in your world you want to talk about?
Working on the Nano, trying to make it a little bit easier. So most of the time when I work on the Nano, I have to get the keyboard out and the mouse out and hook a monitor and run a network cable from that port into my laptop. But I installed a Wi-Fi and Bluetooth radio in here. So now hopefully I can see into it, and then I won't have to connect up all of the two monitors, two mices, and two keyboards.
And that's the Jetson, right? The Nano Jetson?
Yep. So we're using that with this camera, with the Logitech. It's a 1080p camera. And then, using this board for weed detection. So we're running the ROS DarkNet YOLO model, and then we're training that with a weed database. And then we get little bounding boxes. So you have the camera out on your lawn tractor, and then on the ground when it sees a weed, you'll get a little bounding box, and that has a location of where it is. And so then in the back with your sprayer, you can turn on and off nozzles as you go over that weed.
Sounds easy.
I got some Canadian thistle. Yeah. Just connecting.
Little of this, little of that. Zip, zip, zip. You don't have any weeds.
Well, we'll see. That's the project for next spring. Get ahead of the Canadian thistle.
Yeah. Anything else on your to-do list at the moment?
Maybe added some more packages to the Docker container. So I'm going to try to use that sort of the demo platform. And then if there's packages that you like or want installed, we can just keep installing them there.
I think I know the answer, but can I run that in a Windows on a Windows machine?
Yep, that's kind of the Windows, Mac, Linux.
It might be neat to try to get that running on a Windows machine.
Yep. Yeah, and then
for me is step one.
Step one, getting it going. You want to review that launch file for the joystick, or is that all?
No, hey, I'll take any review we can get. Hold on a second. Let me pull up your note.
We can walk through it. You want to go to the tractor teleop.
Well, this is what you had sent the other day.
Yeah, but
go ahead.
We've had a couple people say the same thing. So if you look at the very top here, where you have your ROS launch, simple drive teleop, joy dev, and you're passing in the variable for your joystick input.
Right. At the moment, there are two. I'm using. I've got two ROS launch statements. Simple drive command _vel _mux and simple drive _teleop. I interpreted your note to say, hey, just have one launch file.
Yeah, I can share that. So generally what happens is if you're working on a node, you may just it's all from the command line, and then you'll do you'll just run the Python script. And then once that seems to be working okay and you've got it all debugged and everything goes okay, then we generally take that and move it into a launch file. And so then now you're starting it from a launch file. Right. But as your robot gets bigger and you're adding more topics, instead of having 4 or 5 command screens open and then you're doing ROS launch, then we start to combine those into one launch file. So everything goes from there. So you don't have to pass in the variables. If you go to the GitHub site, you can see how they progress. And I think this teleop one is a okay example because you can
here.
Yep. And then into the launch. So here's an example. If you click on drive teleop, so in this example, a couple things are happening. He's on the this is from Daniel Snyder, just straight from at the very top, he's passing in this variable that you were setting on the command line, this dev input JS0. So if you only have one joystick on your robot, that's pretty much always the same.
Right.
So he did make it a variable, so you can pass in that variable like you were doing when you were launching it, or you just put it into your launch file and then you don't have to worry about it again.
Mm-hmm.
And then he's starting up the joystick driver, which will take in your joystick and then publish that to a ROS topic. And then he is starting the teleop drive. The teleop drive will listen to the joy topic, and then it will, this is the node where you can set what your access is on your robot, and then what buttons you want linked to different areas. And then you'll notice that he's publishing this gets published out to teleop command velocity. Now, this remap is incorrect. What's the one above it? One line above. So the way that we want to set this up, this is an error in here, but we want it to publish on teleop command velocity. And the reason is because we want this joystick node to go through that command mux node. Okay. And then this move base.
Going through the command mux because he wanted to be able to have command velocity messages coming in from multiple places, right?
Yes, like we will have. We'll have one from the safety system, one from the joystick, and one from the autonomous system. And it also allows you to configure other, so if you open up command mux launch, so this will just launch the joy driver, and then it will launch the joystick. And then this command mux is listening to, right now we only have two, we don't have the safety system in the sim. Those two, and then it will output your command velocity, and the output is what drives your robot.
Mm-hmm.
So instead of launching two launch files to get this joystick teleop working, he created another file where you can launch both of them, but just by calling one. So this is how the system kind of, if you look at the introspection of how it's configured, now this one launch file launches two nodes.
Got it.
So it's kind of like step by step by step built onto each other. Now what we would do normally is take this drive launch that's launching both of those launch files, which are launching other nodes, and we would take that and put it into your like base station bring up launch, your base station launch. And so you just type in one launch script, and then everything starts from there.
Yep, I get it. So, I mean, I'll rewrite my instructions to launch this guy after the ones that it's calling have been edited to point to the right place. They're pointing to the right place now. I mean, because I've been able to test to both the steering and the transmission. So,
and then if you want to go into the source of this tractor teleop instead of a launch directory.
Do I want to go into the source of the tractor teleop?
So you click the on next to branch master. If you click tractor teleop. Click source tractor teleop. Yep. And then command mux. So inside of here, if there's a little bit lower. So this is setting your range. So I just want to talk a little bit about, this is the way that I set it up, and open to suggestions. But one thing with the joystick is it goes from -1 to +1. So that's the range for the joystick. Now I use the joystick from off of the cell phone app and off of a Raspberry Pi and my base station. So I'm always sending in 1 to -1. But the autonomous system, when it's coming out of move base, will be from 0.3 to -0.3. And so what I do here in this command mux is I scale that 0.3 to minus 0.3 to 1 to minus 1. So that's what's going on here on this angle. Yep. So now the joystick full left matches the autonomous system or the move base full left. So the robot is getting the same command for full left, full right, forward. So that's what you can do with this command mux. Now you can make this like a ROS parameter if you want to scale the speed of your robot. So if you're driving autonomous, you want it to go whatever the speed move base is telling you, but when you do teleop, you want to ratchet it down a little bit. You can set these different parameters. But
So this is all inside of, I'm trying to remember in my Catkin workspace. I mean, I've got Simple Drive, but this isn't Simple Drive, right? This is...
It is Simple Drive. Some things we've extended a little bit in the sense that we'll have the relays. I control relays from the joystick. So there's a raw service that turns on and off the relays. So we can start the lawnmower or shut the mower off.
Yeah, I'm just thinking through in my own implementation. I mean, personally, I would rather follow your path as opposed to try to create a new path. And I'm trying to get my head around this tractor teleop. I'm not sure that's in my Catkin workspace yet.
It doesn't have to be for your driving around this weekend.
Right. I mean, I get it that this is for the autonomous stuff. Because, you know, clearly I'm still operating with command velocity of -1 to 1 on both transmission and steering. Transmission being speed. So I was thinking I was going to have to find out where that was set and actually increase it to 1.5 because I wanted it to top out at 1.5 meters a second.
When you drive, if you're talking about scaling the joystick, so during teleop, if you want it to move faster when you teleop, yeah. There's multiple places, obviously, you can do that, but having one place where you're adjusting the scale factors may be easier or cleaner.
And do you want to offer a suggestion on where that should be?
Well, see under drive teleop. Yeah, so we just looked at that command velocity mux node. Now under drive teleop, you can see where you're taking this very at the little bit towards the top, right there. So when it receives a joystick message, this is the callback on joystick. You'll see angular velocity is set by your axis. This is axis 0 and 1. We may want to pull that from the ROS parameter server because maybe you want to set your joystick up differently. So these can be parameterized. And then also on this publish, this twist, it's just taking in these linear and angular velocities and polishing it. And so maybe you want to scale it also, have that be configurable through the ROS parameter server. So this is where you can add that functionality.
And so what are you doing?
Yeah, right now it's hard coded, so I have it set up like that, which is not
So this particular source code, you're not using this as is.
No, I'm using it as is. It's hard, yeah. So,
okay.
Yeah, a better approach would be to extend this up, and so then you can make those adjustments on the fly or set them in your launch script, make them variables.
But this is the mapping that you're doing at the moment back on the command velocity mux.
Yep, yep. Basically, it's the angle is the big thing on velocity. Whatever number you send in. So if you send in a 2 to your linear x, your robot will try to achieve 2 meters per second. If you send in a 3, it'll try to do 3. But on the command angles, I wanted the full left and the full right to be lock to lock, or this -1 to +1. So the main thing is this is the twist, is the angle.
Okay.
But I just pass through the velocity, whatever is set by the move base, it will send it. So you can, when you're autonomous system, you tell move base what your max velocity is. You tell your controller what your max velocity is.
Well, step 1, command velocity. Step 2, download your code and try to replicate it.
Yep, and you notice on that one, the e-stop is just does a message. It just it doesn't control your relay on this one. It'll just print out a ROS info. So, but you have your external e-stop, so you're good there.
I mean, my e-stop is a Wi-Fi, I don't know, 900 megahertz key fob deal.
Perfect.
Because I want to go back and implement the USB-based 8-channel relay versus what I've got now is the individual wires. But so I'll get there. So for me, step 1, teleop. Step 2, install the GPS and IMU, and then step 3, try to replicate your software.
Okay.
And I'm sure there'll be a dozen other things in between those 3 steps. Hey, I've got to get that phone call. Guys, have a great weekend. I got to scoot.
Thanks. Yep.
Okay, I'll make some more comments while he's off talking to somebody. So
Okay.
I posted the link to that little board that I was talking about, and I looked at it harder, and it looks like they expect you to do this. So you snap the boards apart, and then these hang off the edge of the Arduino. So the Arduino is actually in the middle, and then the screw terminals stick it out either side. I thought originally it would go on top, and the screw terminals would be right in the middle, but it doesn't fit that way. So if you're going to use it on the real Arduino, it's got to go like this. And the more I looked at it, any of these yellow ones here says it's got 5 volts ground and a signal on each one. So these right here are just for the analog. So you got your 6 analog signals there, and the ones on this side of the board. Ones on this side of the board, it looks like it's got all the ones that say digital. It brings out some pins for those, but it looks like the screw terminals do go to the actual Arduino pins coming out the bottom. So if you're willing to use the pins on the back, then those I think have a corresponding screw terminal on the top. So either way, and if you're using it on Arduino, it's pretty handy because then it gives you the little jumper pins here you can plug your little jumpers into. In addition, because the way Arduino works, it's got the female pins, so you have to plug this down into it. So that's just something I noticed while I was sitting here looking at this stuff. But for what I want to do, I should be able to make it work as a quick way to just connect big wires to little wires, like I was saying before. So I think that's all I really have to say on that.
I like that. That's pretty cool for $5. That's nice to just be able to hook up the wires. Makes it pretty easy.
Yeah. And I'll do some more digging on that. And if anything shows up, I can post the information on that too. So.
Getting better.
And I see somebody, I think it was Ross, just asked what are my encoders hooked up to? He said, what software I'm using to read my encoders on these ones I'm just posting about putting the encoders on our wheelchair motors. And it turns out, again, since we're Danfoss, we have to use Danfoss controllers. And the one controller that's got the 4H bridges only has one quadrature decode channel coming into it. But you can either run it as two wires come in for quadrature decode, or you can use those separately and then read frequency on each pin. And actually you can read, like you can get counts as it runs, so it's counts per loop as it runs, or you can get a frequency that it generates. And I think they're using the counts. I haven't asked them what they're actually doing, but I think they got that working. So they were actually driving around getting real odometry information out of the thing. Somehow they converted whatever this thing's putting out. And it's the same problem that since it's not quadrature, you don't know if you're going forwards or backwards. So you have to say, I told it to go forward, so we're going to increment the number. And I told it to go backwards, so we'll decrement the number. So you got to put that kind of stuff into your software to get around that. And then I was going to respond to his thing on Slack here and point out, but on my mini tractor, I've got 2 real encoders, and I feed those to a like an STM F4 32-bit ARM board, and those little $2 boards has the same quadrature decode in those too. So one of these days I'm going to get all those little $2 boards and see if I can get around any problems that people have come up with so far. I know Al was having problems with I2C, and I think if you just sit and look at it long enough, you can figure out either you're going to get somebody else's library, or you're going to get the right, specify the right pins or something. But so I was going to see if I can get that figured out and figure out, you know, if you use the Arduino IDE, you know, can you make it work just like everybody else is doing? And then I want to find out, say if you're using the Arduino IDE, can you put in your own software to say control peripherals? I know back in the old days when Arduino first came out, they were using that Atmel processor, and on that one you can just talk to the registers directly in that. So I'm guessing on, you know, any of them, say if it happens to be an ARM processor, if you know what the registers are called and what the pins are called, you could probably, you know, talk to them directly. So I want to find out, can I go in through the Arduino IDE and initialize my quadrature decode stuff, because I don't think they have, you know, a direct function to do that, but it'll be worth. They always have the quadrature decode, but it's always done in software on these things, and that's not what I want to do. I want the hardware version. So that's something else. I just want to find out with the Arduino IDE, can I put in enough stuff to talk directly to my peripherals in the processor, and therefore make it do, you know, make it do all the stuff I need to, and still use the Arduino IDE, because that just makes it easier for everybody else. Even though I don't particularly trust the Arduino stuff, because I don't know what's going on under the hood on it. So that's why generally I just start with my own, you know, get a microcontroller and write my own code for it. But, you know, if I'm doing something quick, the Arduino works great. It's just that as you add more and more stuff on, you're not quite sure what it's doing in the background. So I haven't really pursued that too much. Did you have any, did you play with that little $2 board to know, did you run into any problems with it, or?
I couldn't figure out how to program it over the USB from the Arduino. I was able to program it through serial, but not through the USB.
And the only time I programmed it, I just hooked up that little ST-Link external adapter that they gave me. And I was just writing straight C code. So I'd use the ST micro development system, and I write my C code. And then when I go to program, I thought I should be able to hit the button that says program, and it'll talk the ST-Link thing and program it. And I couldn't get that to work, so I had to download yet another program from ST micro that talks directly to that ST-Link device. So I'd have to go to the IDE, create my code, compile it, then switch to the other program, and then point to the hex file and have it program it out. So it got to be a real pain. But so that's something we'll keep in mind, that, you know, trying to get the USB interface to work, so it works just like a real Arduino, and then try to fix the I2C stuff that Al's having problems with. And then if I can get it to do my other peripherals I want, maybe that's a reasonable way to go. Since those boards are so cheap, it'd be nice to just stick them on as little modules and do whatever you want with them.
Yeah, I agree. We tried to get it, the goal was to be able to program it over that platform IO. So we could like SSH into your Raspberry Pi, and then over USB, use that platform IO to update your little device or your microcontroller. Yeah.
Okay, well, we'll have to make up a wish list someday and say, here's what we'd like to see that do, and then maybe we can track that down.
Okay.
And I can't think of anything else right offhand, so.
Right. We we talked about this before, but those little STM32s, be able to put that onto like your servo motor. And then your servo motor, you can read the encoder and then be able to control it. You can send out can over and then be able to move it. Then we could make a pretty cool robotic arm with those 300 kilogram servos. Would make a pretty strong robot arm.
Mm-hmm.
But, all right. That's all I got.
Okay. Are you able to shut the meeting down, or is it going to just keep running?
I think it's going to keep running.
Oh, well, maybe Al's still sitting there. Maybe just off screen. So, oh, I don't know. Well, what is there anything else? Anything else we can do here? We were going to order those hemisphere GPSs, but I don't know if they've been ordered. They haven't shown up yet. If we have ordered them, so that's something that when those show up, that's something else we can play with and see what we can make those do. Can't think of anything else.
All right.
So this will be an experiment to see what happens. We'll go ahead and sign off and then see if there's a big gap after it or if there's some way to chop that off. So okay, I'm leaving now.
All right.
Okay, bye.
Bye.